Hello boys and girls, today we are going to learn how to do metric to standard and standard to metric conversions. So yesterday we covered metric conversions, and now we're just going to add one little layer and add in some standard stuff. Remember that we're like the only country in the whole world who uses, not the whole world probably, but we use feet and inches and miles, whereas most other people use meters and kilometers, etc. So we're going to work going back and forth between those two things. Cool? Cool. We're still using this process. This technique is called, by some, it's called dimensional analysis. And by others, it's called the factor label method. It is so important to embrace this method and use it frequently because it is the key to chemistry. We use it over and over and over and over in chemistry. So definitely go ahead and get used to it, and definitely go ahead and like it, love it, and treat it as your own. Okay, cool. Now, in order to do these kind of conversions, yesterday we learned all the prefixes, mega, kilo, etc. Today we need to learn a few basic conversion factors. A conversion factor is a ratio. It says that one thing equals another thing. Like here's one you already know. 1 foot equals 12 inches. Or 1 yard equals 3 feet. Those are some conversion factors you already know, and you already use them in your daily life. Here's one you may not know. 1 inch equals 2.54 centimeters. That's a common one. That's an important one. Go ahead and be working on memorizing that one. Do you know that 1 mile, that's an M, messy. Do you know that 1 mile equals 5,280 feet? Notice I put MI on mile because if I just put an M, then how would we know whether it was meter or mile? We wouldn't. So I put MI. Or do you know this one? This one is a very important one too. 1 mile equals 1.6 kilometers. And last, 1 pound, that's an LB for pound, is 453.6 grams. We'll probably add some more in as we go. So go ahead and make sure you're familiar with all of these and more, like 1 hour has 60 minutes, which has 60 seconds, etc., etc. Okay, speaking of hours, let's start with that. So let's say that this class is 1.3 hours long, and we would like to know how many seconds that is. Now I know that you can probably work this out without writing this one out, but I need you to write this one out and all of them out because they're not always this simple and straightforward. So let's write it out. I'm going to write down what's given just like yesterday, 1.3 hours. I'm going to draw one bracket. I never really know whether I'm going to need 1, 2, 3, 4 brackets. I just start with 1. And right away, I'm going to put hour on the bottom to cancel that out. Because we don't want hours. We're trying to get seconds. Now, do you know how many seconds are in an hour? I do. But if you don't know off the top of your head, let's just do minutes. Do you know this one? 1 hour is 60 minutes. I bet you do. I bet you do. Now, what that lets us do, notice our hours is canceling out. So now I've got minutes. Do I want to find minutes? No, I want to find seconds. So I'm going to attach a second bracket. I will occasionally have a student who will break the brackets up into parts. I wouldn't do that. I'd do it exactly like this. Why? Because this is the easiest way and the way that works best. Minutes goes on the bottom. Why? Because I have minutes on top. I want to cancel minutes. And seconds goes on top because that's what I want to get. Remember, what you want to cancel is on the bottom. Remember, cancel is on the bottom. What you want to convert to is on the top. That's important. 1 minute is 60 seconds. How do I know where to put the 1 and where to put the 60? Well, it's pretty easy. You should know that 1 minute is 60 seconds. If you wrote it the other way, 1 second equals 60 minutes, that doesn't make any sense, does it? No. Cross these guys out. Okay. Then, how do we solve this? Well, remember, you multiply times the top and divide by the bottom. So what I'm going to do is I'm going to do 1.3 times 60. I'm going to type that in my calculator with you. I'm not going to cheat and pause. 1.3 times 60. Now that gives me 78. Do I need to do anything with that number? Not yet. Should you bother dividing by 1? No, because 78 divided by 1 is 78. Then I'm going to multiply by this top. Now I have 78 in my calculator, so I can just hit times 60. So my calculator says 78 times 60, and that gives me 4,680, and that is the answer. 4,680 seconds in 1.3 hours. Oh gosh, look what I messed up. I messed up significant figures badly. I'm going to put a squiggly line. This is 2 significant figures, so this needs to be 2 significant figures, so I'm going to round 4680 to 4700 seconds based on our significant figures rules. Okay, so just remember, multiply by the top, divide by the bottom. Did I really need to divide by 1 in either case? No. Now there is always a student who says, Mr. Walker, can I multiply the whole top and then divide by the whole bottom? You can. You can. But I've seen a lot of mistakes happen that way, and so again, I like to do it gradually as we move across. All right, let's do another one. Let's say you live 15 miles from Pine Lake, and you would like to know how many centimeters that is. Why you'd want to know that, I don't know, but you know, I can't get into your brain sometimes. Maybe you just want to know. It's just something that you've really always wondered. How many centimeters do I live from Pine Lake? We'll know in just a second. Start off by writing down what's given. 15 miles. Draw a bracket. On the bottom of the bracket, put MI. On the top of the bracket, can I put centimeters? Don't do this, okay? Do you know how many centimeters are in a mile? No, of course not. Who would know that? I don't know that. What can we change miles to? Did you say kilometers? We do know that. It's up at the top of the page. 1 mile is 1.6 kilometers. Miles cancels out. Remember, I'm putting what I want to cancel on bottom and what I want to get on top. Now I'm at kilometers, but I don't need to stop there because I want to end at centimeters. So I'm going to add a second bracket. What's going to go on the bottom of the second bracket? Well, kilometer is km. And on the top of that bracket goes cm, centimeters. Now I know I can do this in one step because this is a basic metric conversion. 1 kilometer, I put the 1 by the bigger unit. Remember, kilo is bigger, so I put the 1 by the kilometer. And then what goes by centimeter? Well, it's the difference between kilo and centi in our metric conversion chart. So kilo is 10 to the third, centi is 10 to the minus 2. That difference is 10 to the fifth. Kilometers cancels out. Here's a hint. Whatever's at the end of the top of the last bracket should match whatever you want to convert to. And if it doesn't, then you haven't paid attention to your units. So now we're going to do 15 times 1.6 divided by 1 times 10 to the 5th power. I get a long number, which I am going to write in scientific notation. 2.4 times 10 to the 6th, I think I count, right? 2.4 times 10 to the 6th. 1, 2, 3, 4, 5, 6. Yep. And that is the right significant figures. There's 2 here and 2 here. Cool? 2.4 times 10 to the 6th is 2,400,000 centimeters. Holy cow. Holy cow. Wow. All right. Let's do another one. That was a nice 2-step conversion. Let's do one that doesn't have 1s on the bottom. Notice both of my examples have ended up with 1s on the bottom. That was an accident. That was an accident. Okay, here we go. How about 3.728 nanograms, ng, nanogram, equals how many pounds? So, how do we do that? We write down what's given, 3.728 nanograms. We draw a bracket. We put nanograms on the bottom to cancel. What goes on the top? Well, I don't know a conversion. I don't have a conversion of nanograms to pounds, so I need to change nanograms to something else. Nanograms can change to grams. 1 goes by the bigger unit. What's the difference between gram, the base unit, 10 to the 0, and nano, 10 to the 9th? Well, that's easy. That's 10 to the 9th. Okay, so now I'm at grams. I've canceled out nanograms. Now I'm at grams. Am I where I want to be? No, I want to get to pounds. So I need a second bracket. On the bottom goes grams to cancel. On the top goes pounds. We know this conversion. 1 pound is 453.6 grams. I gave you that, I think, at the top. Did I? There it is. 1 pound is 453.6 grams. So, how do we type this in your calculator? Well, here we go. We do 3.728 Do I need to do times 1? I can, but what would be the point? And I'm going to divide that by 10 to the 9th. I'm dividing by 10 to the 9th because 10 to the 9th is on the bottom. Remember, multiply times the top, divide by the bottom. Multiply times the top, divide by the bottom. That gives me 3.728 times 10 to the minus 9th. Then I'm going to multiply that by 1. Do I really need to type that? No, I don't. Then I'm going to divide that by 453.6. Divided by 453.6 is 8 and I'm going to round this to the proper number of significant figures, which is 8.219 times 10 to the minus 12 pounds. Cool, huh? Now, again, there will be the students who want to try to get those arrows out of the way. There will be the students who want to do all the way across. I'm going to make this a different color so you can see what I'm doing. Some students will multiply all the way across, write that number down. Multiply all the way across, write that number down. And then what do you do with those numbers at the end? Divide them. That's totally a fine way to solve it if that's the way you choose. That's not the way I do it, but if you choose to do it that way, that is totally cool. Alrighty? Let's do one more example. Let's do an example with... Well, let's do an example with height. So if a student is 6.01 feet tall, how tall are they in micrometers or micrometers? Think about this before we solve it. A foot, well, you know how long a foot is, about the length of your foot. A micrometer is an extremely small unit. Remember that the decimal for micrometer, the exponent is 10 to the minus 6. That means in 1 meter there are 1,000,000 micrometers. Yeah, it blows my mind a little bit too. We're talking like the thickness of a piece of paper, okay? Small, 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 okay? So should we get a lot of micrometers or very few? I hope you're saying to yourself a lot of micrometers. So here we go, 6.01 feet. Bracket, foot on the bottom to cancel. What can I change feet to? Did you say inches? That's what I would do. Because 1 foot is 12 inches. Feet cancel out. Now I'm at inches. Now I want to get from inches to something else, so I put inches on bottom. C is canceling. What can I change inches to? Micrometers? No. Centimeters? Yes. 1 inch is 2.54 centimeters. Now I'm at centimeters. Going to micrometers is easy. Centimeters on bottom to cancel. Micrometers on top. What's the difference between centi and micro? Centi, by the way, is the bigger. Centi is the bigger. Centi is 10 to the minus 2. Micro is 10 to the minus 6. That difference is 10 to the 4th. Crossing out centimeters, and we're done. Now all we have to do is solve this. This is an easy one. We're just going to multiply all the way across the top. 6.01 times 12 times 2.54 times 10 to the 4th power. Why didn't I need to divide anything on that one? What's on the bottom? All ones. No need to divide because all ones on the bottom. Didn't need to divide by 1 because that wouldn't change the number. I got 1, 8, 3, 1, 8, 4, 8. Cool. But this is 3 significant figures. So I need 1, 2, 3. 1 says leave 3 alone. So the answer is 183,000 or 1.83 times 10 to the 6th. Don't forget your final unit, which is micrometer. That makes sense. There should be a micrometer is a very small thing, so there should be a lot of micrometers in 6 feet. Cool? So that makes sense. All right, so we are done with metric to standard conversions, so enjoy. The end.